Hello and welcome. My name is Russ Maxwell, and you've come to the right place if you want to acquire foundational knowledge around AI-enabled Azure functions. I won't dive into some of the basics around building and deploying Azure functions because I already covered a lot of that in my lab series for building and deploying Python-based Azure functions. If you want to ramp up in that area first, please go check out those videos, and I put links in the description. Also, please subscribe to my YouTube channel as it really does inspire me to create fresh content. Without further ado, let's start peeling back the curtains of what would be considered an AI-enabled Azure function. Yes, I will provide an intro to AI here that should shore up some basic AI knowledge so we're all on the same page moving forward. Let's go through 4 slides and then I'll run you through a demo. All source code will be available in my GitHub repo with a link included in the description. AI, or artificial intelligence, is about creating machines, or models in this case, that are capable of mimicking cognitive functions, such as learning, reasoning, and problem solving. It all starts with a model. The model is fed a large amount of data and is trained on that data to recognize patterns, make decisions, and predict outcomes. Training can be resource intensive for a few reasons. Number 1, the size or amount of data being trained. Number 2, complex algorithms performing a bunch of mathematical operations. And finally, number 3, it's iterative. As the model trains on data, it's learning. So these operations are performed over and over as the model is adjusted to reduce error rates. This is why you'll hear the word GPU-based processors, because those processors excel at training models because they can do parallel processing where the traditional CPUs only process sequentially. The end result is a fully trained model ready for input. Okay, let's talk about types of models. And when I say model, I'm really referring to a machine learning model, also known as an ML model. OpenAI has produced multiple models. Some popular models include GPT-4 series models and the more recent O3 model. Next up, I like to call these community-based models. These are models created by anyone and available to everyone. Hugging Face is the home to the largest collection of community-based models. I like to think of Hugging Face as the GitHub for ML models, although they have popular transformer library as well. As a consumer, I can access Hugging Face and select one of these models, fine-tune it, which is to train it further, and start using it. You also have what I call CYOM, and that's create your own model. So you can build one from scratch where you train on data and make adjustments as necessary. Popular Python libraries like PyTorch excel in helping developers train models. So you have the option to use a fully trained model that you fine-tune, or create your own model to start from scratch. Obviously, a fully trained model, like selecting a GPT series model, is the fastest way to get going, but you can absolutely train your own model on a predefined set of data. Cool. So next up, you have the various model types available from Google. That includes BERT and T5 models. Meta produced the Roberta and Dino models. Amazon has produced the Deep AR model. And finally, Microsoft has the Turing NLG model. Like the alien on the right, you might be wondering, how does ChatGPT fit in this picture? Well, ChatGPT is primarily an interface that leverages models on the back end produced by OpenAI. So where are these pre-trained models, and how do you use them? Pre-trained models are available on most major cloud providers. The Azure OpenAI Service provides access and hosting of models. The most popular models available on Azure OpenAI Service are the OpenAI-based models, although other types of models are available. We will use the Azure OpenAI Service in the demo later. Next up, from Amazon, there's Amazon Bedrock that provides access and hosting to several types of models like Nova, Titan, and Llama-based models. Next, you have the Google Vertex AI. That's also capable of hosting models. Available models to choose from are the Gemini series, the Palm series, and the Cody series. Finally, you have Inference Endpoint from Hugging Face, which is a fully managed service where you can deploy a model directly from Hugging Face's Model Hub. So in this demo, I'll use the Azure, more specifically the Azure OpenAI Service, to host my model. Let's hit one last slide and talk about the scenario. Let's assume I want some AI analysis performed on errors being reported in my web application. That's the top left. And on the right, you can see I've got logs being sent over to a log analytics workspace. I have alerts set up so that when exceptions occur, the alert is triggered and sends an email to the administrators. I want to add some AI enhancements around this for additional details about the exception, including potential causes and steps to resolve. That's where the AI-enabled Azure function comes in. I'll build an Azure function that calls into a model hosted in Azure OpenAI that provides the exception details I'm looking for. I'm including instructions on what I want the model to do with the data provided, as well as include exception details within the request. I should note that this will be a two-part video series. The first video will be focused on getting Azure OpenAI set up and an Azure function wired up to the model. Finally, we'll be testing the model by calling the Azure function within a browser session and pass the exception details. The end result displayed in the browser should provide a response that includes potential causes of the exception and mitigation steps. In part 2 of this video series, we'll wire this up to the Azure alerting solution I showed you on the previous slide and take in requests from the Azure alert and email details directly out of the Azure function. Without further ado, let's go ahead and demo. I'm in the TrainRG resource group. I just created it, and let's go ahead and get started. So first off, I'm going to create the Azure OpenAI Service. So click Create. I'll type in Azure OpenAI. And then obviously I want the Azure OpenAI here, so I'm going to hit Create. And one thing to point out about regions is the region you select matters. Some of the newer models are only available in a subset of regions. So if you're not sure, look up the model and the region availability within Microsoft's documentation. So I'm going to go with West US, and I'm going to give it a unique name. You guys probably noticed my lovable Boston Terrier on the very first slide. So I'll call this one Boston AI. Let's see if that works. It does have to be unique. So, hey, it worked. I'll go with the standard plan. That's fine. Hit next. I'm good with all networks. Next. Let's create it. All right, it took a couple minutes, but it's complete. I'm going to hit go to resource. Notice if I go into the OpenAI service now, there's not a whole lot of options in here in terms of managing the specific AI piece, right? There's some resource management. Some of these options are common across Azure resources. So really not a whole lot I can do as far as management of models within this resource. That's because Azure OpenAI Service hooks into Azure AI Foundry. Azure AI Foundry is a platform where you can select, fine-tune, test, and deploy your models. So notice at the top, I have a button, go to the Azure AI Foundry portal, and that's what I'll do. So there's two ways to get to this. Number one, I could just click the button, which is what I just did, or I can go to ai.azure.com and log in. So the first thing I want to point out is the model catalog, and you have different models to choose from. These models have distinct attributes that would prompt you to choose one over the other. So for example, if I want a model to generate images from text input, I'd go with one of the text to image models. As of the date of this recording, that would be the DALL-E 3 or DALL-E 2 model. The chat completion, that's what we're gonna go with. And this type of model will generate responses as conversations. So this is a more human-centric approach, and you can engage in conversations with the model, or a more simplified Q&A approach where you're just looking to get a single answer back and move on from there. I won't go through all of these models and what they entail, but I would encourage you to go read up on these different types of models. So again, I'm going with the chat completion model. Specifically, I'm going to go with the GPT-4o mini model. And I'm mainly going with this model because it's a lower cost approach. It's important to read the fine print to see how up to date these models are with the information they're trained on. So notice this model, it's trained with knowledge up to October 2023. I'm okay with that data set up to that date because I'm looking for a model where I can submit general errors produced by a custom.NET Core application and get feedback on potential causes and mitigation steps. In any event, let's deploy it. Okay, I'm gonna give it a name of my Boston GPT-4o Mini. I'm gonna go with a standard deployment and deploy. I'm good with the remaining settings. Okay, great, it's deployed. Please take note of the most important part of this page. That's the target URI as well as the key. The endpoint is how I'm going to call into this model from my Azure function, and the key is going to help me gain access. I'll copy this URL and key off for later use. To test this model out, I can submit some examples of what I expect to send to this model. I plan on sending general errors that are produced by my .NET Core application. So I want to use the chat playground, and to access that, I can either choose open in playground or select chat from underneath the playground section. Just like a kid exploring a playground to see how high they can get on a swing or how fast a merry-go-round will go, the same concept applies when testing your models within the chat playground. This is a great way to ensure that your model is responding to specific requests that meets your expectations, and most importantly, the requirements. So notice under deployment, my model is already set. I'll give the model instructions of what type of data will be sent and what is expected to return as a response. Okay. So my model instructions, you will accept error messages generated from a .NET Core application and provide why the error is occurring and possible mitigation steps. This is referred to as a system prompt. It's a set of instructions you give the model and your expectations for how the model should respond. This is prompt engineering 101, where you define a prompt, and that includes a system prompt like the one illustrated, and a user prompt, and that's the data you're feeding the model. In my example, I'm going to submit an HTTP 500 error. So I'll drop that in over here. And I do need to apply this system prompt. So I'll click Apply Changes. And let's send it. Notice I got quite a verbose response from that model. This is important to understand because this comes at a cost. Each request and response consumes tokens, which are units that measure the amount of text processed. The more tokens consumed, the higher the cost. Tokens can include words, punctuation, and even spaces. So you can control the number of tokens used in a transaction like this one by setting the max response. By doing so, you can manage both the verbosity of the response and the associated cost. The default for this model is 800. So where do you see the max response value? It's a parameter. So if I come over here under parameters, notice I have max response, it's set to 800. If you're curious about some of these other parameters, you can always click on the icon next to the name. It'll give you more information. So now we have a model that's deployed. We have the endpoint information. Let's plug this into a new Azure function and test it out. All right, I'm back in the TrainRG resource group. I already created the function app just because it's an easy process, and I covered a lot of this in the intro videos I did on Python-based Azure V2 functions, so go check that out. Next up, we'll create a new function within VS Code. We'll write the code to AI enable that Azure function, which is simply to ensure that Azure function calls into the Azure OpenAI Service and to submit our request and then process the response back and display it in the browser. Let's go do that. All right, I'm now in VS Code. I opened up an empty folder called sample func. And before I get started, my local machine is currently set up to install, run, and debug Azure functions locally within VS Code. If you want to follow along, I'll include a link to my local machine setup guide in the description. All right, so first up, to create an Azure function, I will go to View, Command Palette, or Control-Shift-P, and I will type in Azure Functions. And notice at the very top I have Create Function. Okay, select my folder, it's fine. Select language, I'll choose Python. I'm going with the V2 model. My function app's running the Python runtime 3.11 version, so that's what I'll select here. So what type of function do we want to go with? And we're going to go with an HTTP trigger because in the next video, that's what we're going to use it for. We're going to call in to that function via an HTTP trigger from the alert. Finally, I'll give it a name. I'm going to call this process alert because that's the eventual goal of this particular Azure function. I'll go with anonymous and let it create. All right, function's created. Let's drop some code in. Okay, let's activate the virtual environment. All right, we're good there. And then we need to add a couple packages. So I'm in requirements.txt. And I've added Azure Identity as well as OpenAI. Let's save that. And then let's get those dependencies installed. Okay, we're good. Let's hop back into our function app PY. Okay, so starting off, we're going to import the classes we intend to use from those modules. So that's the default Azure credential as well as the Azure OpenAI class. That's the important one here because it contains all the functionality we need to interact with the Azure OpenAI service. Okay, next up, let's focus on the actual function itself. Instead of writing out the code line by line, I'm not going to bore you with that. I'm just going to copy the code in and we can talk through it. So I will remove the default logic and I will paste my code in. I won't cover the Python basics in describing the code that applies to the generic Azure function, as I already discussed this in my previous video series. But I will talk about the code that applies to the solution. In this example, I'm stuffing all the logic within the Azure function to simplify this as much as possible. In the next video, when I integrate this into my alerting solution, I'll organize this a bit better by adding additional functions. So the very first thing I do on line 12 is tap into that request, and I get the value of the name parameter. If that value equals getInfo on line 14, then I attempt to retrieve the second parameter called message from the request. You might be thinking, what is he talking about with parameters? Well, when you call an Azure function based on a trigger, you pass a URL in that can include parameters in that URL. So for example, I could do something like this. Assuming I'm typing that into the browser, it always starts with the URL to the function app /API, your function name, and then followed by parameters. In this example, I'm passing parameter 1 with the value 1 and parameter 2 is a value 2. So that's what I'm referring to within this code. That's how it maps out. Next, on line 16, I'm pulling the value of the message parameter and I'm assigning it to the error submitted variable. So moving down, notice on line 18, I immediately hit my try block and I start building up the code to talk with Azure OpenAI Service. I overlooked something. What if there's no message parameter passed in and error submitted is null or contains an empty string? I need to handle that. I could create a nested if, but I'm not going to do that. I'm going to correct this by doing the following. I'll just move this up to line 13. And then I will add an and to my existing if statement and just ensure that error submitted contains a value. So moving into this try block, on lines 20 and 21, I need to pass in the endpoint as well as the key that was produced after I created the model. Usually you won't hard code any keys in your code because usually in this case, that would be stored in Azure Key Vault. I'm not gonna do that this video, but next video, I'll create secrets that represent those two values and we'll call into Azure Key Vault to retrieve them. But for now, it's fine. Okay, moving down, line 24, that's my system prompt, the set of instructions that I provide to the model so it knows what I expect in terms of a response back. Right now, it's just a multi-line string assigned to a variable called sysprompt, but we will use it later. Moving down to line 29, I'm instantiating a client object for the Azure OpenAI Service. I'm passing in the AI endpoint, the AI key, and the API version I'm using. The client object allows me to interact with the model I created earlier. Starting on line 30, I'm using the client.chat.completions.create method to create a chat completion. I'm passing multiple arguments to this method, including the name of the model, a list assigned to messages that contains my system prompt and user prompt. Moving down to line 43, I retrieve the response and strip off any white space from the content and assign it to the RESP variable. Finally, I return that cleaned up response to the caller, which in this case will print to the browser. Let's test this locally. First, I'll need to do the Azure Write Start. And then I will go ahead and start it. All right, so it's available. Let's go ahead and call into it. I'll just open a browser. So good, it's responding. It does have the message to pass in my parameters, which I'll do. So first, I need to pass in the name parameter, and this is going to be getInfo. And then the second parameter is separated by an and. This one's called message. So in this case, I'll pass something a little different in. I'll pass in the system.argument exception. So there you go. I called in the Azure function. It submitted my request over to OpenAI, got the response back, and printed it here. So good stuff. Let me mention this. If there's any takeaway from this portion of the training, it's to make sure you test your functions locally. And the reason I say that is because sometimes you'll have syntax errors or something that will prevent that code from running. And it's better to find out locally, because if you deploy that up to an Azure function, oftentimes what will happen is the deployment will work fine, but you won't see any Azure functions and you'll be banging your head wondering why. Because there's very little logging that comes with that scenario. Again, make sure you test your functions locally. Make sure they run the way you expect them to. Okay, let's go deploy this to my Azure Function app. Interesting, I came back to VS Code. Notice I have this nice error, and that the Azure storage connection string is either empty or invalid. It doesn't like the fact I don't have a connection string set up to the storage account in Azure. So a function app will leverage a storage account for storing diagnostic logs and other information. And if I go to Azure Portal, you can see the function app created a storage account. I need to wire this up in my Azure function so it knows how to access a storage account. To do this, I'll just copy the connection string. So I'll hop into storage account, I'll click access keys, and I will copy this connection string. And let's drop this in VS Code. I should note that this error applies to running my function locally. Your local configuration settings are in the local settings.json file. Let's take a look. In regards to this error, it depends on Azure Web Job storage property containing a valid connection string to the storage account. So that's where I'm going to copy it. Looks good. You might ask yourself, what about after I deploy this to my Azure Function app? Will I get the same error? By default, you shouldn't, because the Function app automatically has an app setting set up called Azure Web Job Storage that contains this connection string. Okay, so I'll stop debugging and let's deploy this out. All right, I'll click Azure over here, which is part of the Azure Tools extension pack. I'll go ahead and sign in. All right, I'm signed in. Let me expand this. I'll expand the Function app. I'll right click on that and deploy the Function app. Good news, it succeeded. Let's go check it out. All right, I'm in Azure Portal. I'm gonna click on my Function app, and there's my function. So great. Let's click on the function. So clicking on the function, I like to run the get function URL. It's my lazy approach to grab the URL that's going to be called within the browser. Doesn't matter which one you click. All right, so opening up a browser, this was my test with localhost. Obviously I'm deployed now, so I want to update that. So I'll just go to the beginning and paste it in, and then I'll just delete everything up to process alert. So I have my parameter set. Perfect. Let's try this out. It worked. Excellent. Let's try a different error. All right, so I'll just replace the value with the system.object_disposed exception. And now I have a completely different cause as well as mitigation steps. So this is extremely powerful. There's a lot you can do with this. And this is just scratching the surface. Stay tuned for part 2 of this video where we're going to bake this into our alerting solution. See you next time.